Right, welcome everyone to our second community meetup. Thanks for joining us. So today we've got 4 talks coming up. First off, I'll be giving you a presentation on GitHub Actions and how you can use it with Civo. Then we've got Johannes Tegnér. Hopefully I haven't mispronounced it too badly. I see him laughing in the video. He's one of our fabulous community members and he's founder at GitOps. And he'll be talking about continuous deployment and the process of automatic deploys. Up third, we've got Sam Weston, who's a DevOps engineer at Pulse Live, and again, another member of our community, talking about Prometheus Operator and monitoring. And then finally, I'm sure most of you probably know him because he talks to everyone, Kai, our developer advocate, who'll be talking about auditing your infrastructure as code setups. So GitHub Actions is a platform for you to automate your entire workflow from things like any running automated tests, packaging your application to various formats, or deploying out to staging, production, or any other environment. The good news is even on the free plan, GitHub fairly recently announced that you get 2,000 minutes per month free. So everyone can try this on public or private repos, and you get a certain amount of free usage. We have a GitHub action, which is a pre-composed step for using the Civo command line interface in your GitHub workflows. And thank you very much to Alejandro for adding that to the marketplace for us. So what we're going to deploy today is a sample application. It's a very simple Ruby application using bundler. And all it's going to do is it's going to listen on HTTP and respond to a request to the root with hello world. I'm not a great Ruby developer. I'm quite new to it, so that should be enough. We're going to build that into a Docker container because obviously we need to deploy that to our Kubernetes cluster. So this is a fairly standard Ruby Docker file. And we obviously therefore need to create a Docker Hub repository, which I've already done. This works with private repositories, and this will demonstrate today on using private repositories. So for your own applications, you can keep them secure from prying eyes. And you need to create an access token so that we can actually push images out to our repository. So in GitHub, you have the concept of secrets, which are values that you want to provide to your workflows, but not necessarily have committed into the repository so that everyone can view them. So in this case, we've got the Civo token, which is just our API token, and the 3 sets of Docker credentials we need in order to be able to push to it. To deploy an application to Kubernetes, as I'm sure most, if not all of you are aware, realistically, you need 3 things. You need a deployment, which describes the Docker image that you're going to run, how many replicas, things like that. You have a service so that you have a single endpoint for all of your different containers within your deployment. And you have an ingress route. Now, what you may notice on the ingress route on the right-hand side is that we don't know the cluster ID at this point. So there's just, in all in capitals, cluster_ID. So we'll replace that later with a real one. A workflow in GitHub Actions looks like this. It's a YAML file in a .github/workflows folder. You give it a name and you describe when it's going to take these actions. So in this case, whenever we push to the master branch, or if someone raises a pull request that will get merged to master, run this action. You then have a list of jobs. Each job has a label. So in our case, test app. You describe what operating system it's going to run on. So this is a sort of containerized environment within GitHub. And then the actual steps you're going to execute for this job. So broken down into a number of steps for what we're going to do today. The first step is we're going to build a Docker image. So we first off start by using the standard action/checkout action, which is going to clone our repository onto their working environment. And then we use Docker's action that they've built, which will build a Docker image and push it out using the GitHub secrets that we previously defined. After that built, we'll install the Civo using our Civo action, and again, specify the Civo token from our secrets. Now we go into the Civo specific things where we create a Kubernetes cluster. I've chosen just to use the default instance size and 3 nodes. We then download the Kubernetes config to be able to connect to it. And finally, we just loop waiting to make sure that we can actually connect to the API. Sometimes there can be a little delay between the cluster being ready and Neutron eventually sorting itself out and letting you have external access to it. So we just loop to make sure that we can get access to the API before we continue. Now we need to pass our Docker Hub credentials into Kubernetes so that when it tries to pull our sample application, it can authenticate as us. Now we're ready to deploy the application. So the first thing we do is, using the Civo command line tool, pull down the ID of the cluster that we've created. And we replace that cluster underscore ID in our YAML file with that value. We then apply the YAML file to the environment and wait for it to be ready. We're just going to loop, check in kube control rollout status to make sure that it's successfully rolled out before we continue with the next step. There's no point doing this while the application is trying to pull the image or the ingress route isn't set up. You then do whatever steps you want to do to test your application. So we're going with a very simple example. We're just going to curl our /endpoint and make sure that the output matches hello world. In this case, in reality, you could hit an endpoint that tests your application's internals, make sure it can connect to the database, things like that. Whatever test you want to run, but this is now running in a full Kubernetes environment. Finally, unless you actually want to pay for a cluster for every time you push, you need to clean up the resources we've used. So the only difference is really in this one that you haven't seen before is that we have a needs test app, which means that don't run this in parallel with running the test, because there's no point trying to clean up a cluster that may not exist yet. And the other item is the if, and then the GitHub syntax to say always. The reason is that whether the previous test passed or failed, we still want to delete the cluster. We don't want to necessarily keep the clusters running around long term. So in the GitHub interface, it ends up looking like this. On the left-hand side, you can see that we actually managed to do a full run in 5 minutes. So getting the cluster up and running, Dockerizing our app, and running the tests, and tearing it all down afterwards and cleaning up nicely. And that includes, unfortunately, a slower than we'd like cluster launch. So we hit 3.5 minutes on this one. Normally, we aim for around 2 minutes, and we're hoping to get that down further this year with the Cube 100 platform. But either way, this is still a 10 pence build in approximation. So you can check out the full code at this repository, and Kai is going to be writing a learn guide on this GitHub Actions flow very soon, but hopefully it's all fairly understandable in how it works. There's Q&As, Ricky. I see you're muted. I don't know if these relate to this talk or if we want to save them to the end.
Just looking at it now. We can go through this one now. It's from Ian. Is there support for GitHub registry-based images? Some of the businesses would be using GitHub registries since it's built into the service itself. So some of these people would be using GitHub registry as a private registry.
As I understand it, there's currently a conflict between GitHub registry and K3S. I saw someone posted in our community channel on Slack this week saying they couldn't get it to work and I couldn't get it to work either. And I believe it's because the GitHub registry doesn't actually implement the full specification that Kubernetes requires to pull images from there. So hopefully when that conflict incompatibility is resolved, it will work. But it's down to, I believe, GitHub to fix the registry and implement these extra fields that they're not supplying that the other Docker image places do. But as I understand it, you can use the Amazon registry, Key, Docker Hub. I haven't tried it with GitLab's built-in container registry yet, but I believe that works because we deploy from it. So yeah, I think it's just a GitHub issue.
Have we lost Andy?
Oh. Can you hear me now?
Yeah, we can hear you now. Just lost you for a sec there.
My microphone just decided to die, apparently. Technology.
Okay, I think we've lost Andy again there. Maybe you have some microphone issues, it looks like it. But Kai, I think he's pretty much wrapped up there.
Yeah, so I guess we could just,
Yes.
if we, just go on straight to Johannes's presentation.
My Zoom has crashed, apparently.
Okay, Johannes, hopefully you've got a working machine. You can take it from here.
Yeah, I think so. I hope so too. I'll take over the screen real quick. Let's see. There we go.
Okay, looks good.
All right. Yeah, hi. My name is Johannes Tegnér. I've been working with development for quite a while, about a decade. And before that, I studied it. And my main area has been backend for many years. But the last few years, I moved more and more towards operations, DevOps, that kind of stuff. And I worked quite a lot with Kubernetes the last few years. I found Civo a few months ago, and I was quite intrigued by the managed K3s, something that I'm quite impressed with too. So yeah, I wanted to take them for a test drive, and it seems to work very well. So today I wanted to talk about continuous deployment, something that I find very, very useful with Kubernetes. To do this, we need a cluster, which I think most of us know how to get it up and running. I have created a cluster before so that I wouldn't have to mess that up in this talk. So yeah, I thought I would talk a short bit about how I think when I work with automation. Every command I write in my scripts, I write them as I was doing it manually while working. I test them in a container or directly in a Docker file to make use of the Docker cache. And when a command works, I move it over to the actual script, and I keep going like that until it's up and running. I don't optimize in the first pass. I just want to get something up and running, and then I make it better later on. Yeah, let's see. So we got quite a lot of different engines for continuous integration and deployment. I use GitLab and their system for my files. They've been around a while and have developed quite a nice tool for continuous integration and deployment. There are many others. We just saw an example with GitHub. We got stuff like Jenkins and yeah, a lot of others. But if it's built into the Git provider, it's quite easy to get it to run right away. Yes. So to start off, when I deploy, I never want to deploy with a user that is root. So I always create a deployer service account. I put it in the namespace that it should be using instead of allowing it to use all the namespaces. And yeah, I could show the sorry. It's quite basic. It got access to the resource that it could need, but I don't allow it to do very much. I allow it to update and patch and also check deployments and pods and services and stuff like that. So I always manually deploy for the first time when I deploy, while I then let the deployer, the script, patch it later on. So as this project that I already set up to, which I'm showing here. We need to export the Kubernetes service count information and put it in a config file to be able to actually access the cluster. So I put together a small script, exports it. No, sorry. Exported them and quickly create a config file. And here we go. So I bring this with me to and now I have added it to the repository so it can access the cluster API. So CI and CD is nothing without the scripts, of course. To get the most out of the pipelines, you will want to run all your tests before any deploys are made, and make sure everything works as it should. So I usually, before I deploy my first version, I always run the tests in the development branch and merge it into the master branch, which I use to deploy. This is a script for the Kube demo project. It's quite simple. All it does is it tests the code. In this case, it checks if the file exists, and then it only does this on the development branch, or on all branches except master. As if it's merged into master, it's already tested from the other branch. While the master branch will containerize the application. So when it runs, it tests on the development branch, and on the master branch, it creates a container. This needs to be done before actually deploying manually too, because if we haven't, there won't be an image to actually deploy as the application. Now let's see. So the deployment. It's a quite basic deployment file. It contains a deployment and a service. The service uses a node port because it's easy. I could have used an ingress like Andy did, but I thought better to keep it simple for now. It got 5 replicas, and it uses the rolling update strategy. I find this quite important because then I can choose how many versions, how many pods are running while it deploys. So right now we got it running, and this is the cluster, and this is the page. So so I thought we should try to do a deploy with a deploy script. So we can jump in here into the web IDE. And I created this a bit before, just to make sure we can change the index file to. Commit. In this case, I commit to the master branch. It should be protected and only accept pull requests. But in this case, I'll do it this way. So now, now we can jump to the pipelines and check what happens. Let's start with containerization, which is done with Docker and a CLI plugin called BuildX to allow some extra syntax and to allow multi-platform support. So let's see what happens when we deploy. Now I use kubectl directly as a executable in the image that the runner uses, but you could basically use curl or whatever to patch the image. So now, as you might see, all the pods have been updated and the old ones removed. They were updated quite fast because they have no startup health checks, but yeah, it seems to work. So now we got a fully functional script, which every time we push to the master branch, it will deploy a new version without any downtime for the users to be annoyed. And I think that should be it.
Okay.
Johannes, I had a question about BuildX.
Yes, of course.
She said, "I'm curious how." Oh,
sorry, your mic dropped.
And your thing's gone. I'll read it out for you. I'm curious how Docker BuildX's performance when this is run in production. Actually, I'm curious about the performance when this is run in production, considering how it's still on the edge branch, as far as they're aware.
Yeah. Well, I don't really use it in production. I use it to build the images. When the images are built, it can be deployed to any architecture that you build it for. In my case, I mainly use AMD 64 and ARM 64. And the steps when it built, it uses QEMU, which is single core and quite annoying to use. So I usually build it on the actual platform, all the binaries, and then import them into the container, into the image during the containerization script. So it works, but I wouldn't build CPU heavy images with.
Cool.
okay. Thank you very much for that.
Thank you too.
Okay, let's hand over to Sam Weston now for his talk.
Oh, right. Let's see if I can screen share. Great. So yeah, my name's Sam Weston. I am a DevOps engineer for a company called PulseLive. We build websites and apps for some big sports organisations, football clubs, Premier League, kind of big sports organisations you've probably heard of. So yeah, I'm just going to talk about when you've got this new shiny K3s cluster you spun up with Civo Cloud, how on earth do you then monitor it, make sure it's working in the way you expect? It can obviously be a problem that's quite daunting because there's so many moving parts with Kubernetes. How do you know that you've got all the right monitors in place to monitor every aspect until that particular thing breaks for you and then you know to add it? So the cheat that I've got basically is something called Prometheus Operator. So that's something that CoreOS developed quite a while back, and it's basically a way to configure Prometheus with YAML. So rather than having one big config file, for example, to configure your monitoring, you can deploy your monitors or your alerting, everything alongside your application. So I've got some examples basically that I can go over, and yeah. So I'm assuming here you've already got a Civo cluster and you've already got all that running up and running, and your kubectl command is installed and working. So again, I've cheated because we're a bit short on time. I've already deployed all this stuff, but I'll show you all the commands that I ran to deploy it. So yeah, and I've also posted all the resources on GitHub, which we'll link around after this is finished. So you can go and copy and paste basically what I've done, so you can run it on your own cluster. So yeah, so I'm going to run a Helm deploy, which of course isn't there because I just copy my README file from my GitHub repository. That's the easiest thing. So to install, it's just a simple Helm install. So go and install Helm 3. Again, the link's on the GitHub repository. The values file, I'll go over now while that's running. So the default values that come with it are great because they have a lot of monitors installed, a lot of alerts and everything that you'll need for most Kubernetes clusters. I think they cover pretty much everything that you're going to want in production. There's a few things I've had to turn off because it doesn't quite work with K3s. For example, etcd, the version of K3s that we're using in Civo, I don't think has etcd. It uses a different backend for storage. And Kube Controller Manager and Kube Scheduler don't work, I believe, because K3s is one binary, whereas traditional Kubernetes has got a whole load of different services to run. So I've just turned those off in my Helm values file. In this case, I'm sending all my alert manager alerts to an SMTP server called MailHog, which is a really great testing tool actually for just receiving. It's a dummy SMTP server with a web UI. So you can see here, I've had one alert go to it that I've just had a test alert basically. It's a dummy SMTP server, which you can run in your development environment, so you don't have to set up hooking into Gmail or Office 365 or whatever your actual email server is. I've got some commented out bits here, which is what you do if you wanted to hook it into Gmail. You can also, at work, we use Slack, so we have it send Slack messages using a Slack bot token. I've also sent a few alerts which come with it to the null receiver, which means that they won't go to my email inbox. They'll instead just basically be muted. You might choose to mute different things. These are things which in my cluster I don't care about that much, so I just don't want to get alerts for them. And yeah, here are my receivers. So I've got a null one and an email one, which is your email at gmail.com. So you'd probably set that to something different. I've also got inhibit rules. So one great thing about Prometheus and Alert Manager is that you can have the same alert with the same name, but you can tag it differently. So if I have the same alert with the same name tagged warning with one set of parameters, and I can have a different alert that's critical with say a higher error rate or a higher latency, so things are slower. So you can have two levels. So maybe have two Slack rooms or two email inboxes, one for your warning alerts, which are kind of things are a bit bad, and one for critical where the big guns get involved for those critical alerts. So that's really useful. I've also set a persistent volume for Alert Manager. I've upgraded Prometheus, but generally speaking, the default settings in here are pretty good. You'll also see there's a load of commented out bits, which are more kind of things you might want to set if you're running it in production. So Kubernetes resource limits and requests. The one big thing with Kubernetes that trips people up when they first use it is they don't set their, especially requests. Limits are important, but requests are really important. So you end up with Kubernetes scheduling pods that need 5 gig of RAM or something like this one does on a node that doesn't have that much, because you haven't told Kubernetes that you need that much RAM. So your cluster, it's especially important with K3s because you can run pods on that master node. And if your master node falls over, you're in big trouble. So yeah, when you're running this in your environment, definitely look at uncommenting that and working out. I'll show you some dashboards that can help you do this actually. Work out how much RAM you need and set these CPU requests, especially, and RAM requests, because you can get yourself in big trouble. So that's basically the values file. It's more or less, you can go into GitHub and look at the official Helm chart with the default values, and they're pretty good. So that's a good start. One caveat with this demo actually is you need to be using the development version of Civo when you spin up your cluster. The version 1.0.0 that comes by default, for whatever reason, some of the monitors don't quite work. So I spun this cluster up that I'm using with the development version. And you also can't use it on Raspberry Pis at the moment with ARM64 because some of the Docker images in the Prometheus Operator chart don't have ARM64 builds yet. But fingers crossed, it looks like ARM64 is getting a lot of traction, and that's really improving fast rate. So maybe in a couple of months, you'll be able to install it on your Raspberry Pi as well. Great. So let's go back to my terminal. My install's finished ages ago because I've spoken for ages. So that's now installed. That's installed Prometheus. It's installed Alert Manager, which the sole thing for all Alert Manager does is routes your alerts that come from Prometheus for your problems that are going on to email or to Slack or something like that. And it's also installed Grafana with a whole load of dashboards, which you'll need. So basically it's out of the box, got most of what you need. So let's start with Prometheus. So let's show all alerts, all the rules, actually called Prometheus rules, but they're alerts that go to your email inbox. Most of these are green because nothing's broken, which is great. You can see there's a whole load of stuff about how much disk space is left on your volume, whether some nodes are failing, whether, there's just a whole load of stuff that is things you need to monitor in production when you're running Kubernetes. I mean, pretty much in our environment at work, we are using pretty much all of these monitors out of the box, and we don't have to add that much because it's the community is just covered basically everything you need to monitor. And even things in your application, like if your pods in your application are crash restart looping, if your daemon set rollout stuck. So even your application gets monitored to some extent with these default alerts, which is really great. So this is the Prometheus web UI. You'll see on my GitHub page, I'm running port forward here to forward Prometheus, Grafana, even Mailhog to my local machine because I haven't set up Ingress. You don't get any authentication with Prometheus to start with, so the easiest thing to do is not expose it to the internet. You can stick things like Google OAuth in front of it with third-party tools. You can stick basic authentication on top of it, which is a really easy thing to do using Trafic, which is the ingress that comes with K3S. But for the purposes of this demo, let's just do port forwarding because it's the simple option. This is the Prometheus web UI. You won't really use this that much. You can see the rules and what's failing. Let's turn that off. And I can just see the watchdog is, I'll get into the watchdog in a bit, but that always alerts. And then I've got one container that apparently is having a lot of CPU throttling. So that's only a warning. That's not a pending alert, sorry. So it's not actually going to fire and email me yet because it needs to have that problem for a bit longer to get the email. So yeah, Alert Manager, not very exciting. Probably not going to look at that web UI a great deal. But the great thing is Grafana. So all these dashboards, except two, which I'll go over in a second, are included out of the box. So you get, API server metrics. Can I go back? There we go. You get cluster compute resources, so you can get a feel for how much RAM and CPU are full up on your nodes. And you can look. There's a load of stuff for compute resources. You can drill down into individual nodes or individual namespaces or individual containers and workloads. So really great stuff there. And so what else have we got? We've got networking. Another caveat with K3S. So the default volumes, persistent volumes in K3S use local storage. That volume driver does not export metrics in a way that this picks up. So if you want these shiny metrics, you're going to need to install things like Rook, which I think are on the Civo marketplace. So some other slightly fancier volume thing than the persistent volume driver than the built-in local storage one. But other than that, I mean, if you go through these dashboards yourself, you'll see that pretty much all of them are there. I shouldn't pick that one clearly. But generally speaking, the compute resources stuff is really useful. Networking, stateful sets, nodes, quite nice. I can see, again, resources on your nodes. So great. Why haven't I gone over? Yes. So in addition to that, in my GitHub repository, again, I've applied a bunch of YAML files for traffic monitoring, because that's not going to be in every cluster, so it's not in the Helm chart, but it's really simple because it's all Kubernetes YAML with the Prometheus operator. I can just deploy service monitor YAML with just kubectl apply, which will just hook Prometheus into the Prometheus metrics port that already exists on Trafic and will already exist on loads of cloud native stuff. If you've got your own application, it's really easy to add metrics with Prometheus compatibility. So that hooks Prometheus into it so it can see metrics from your app, or in this case, Trafic. I can add Prometheus rules YAML, which is, as I said, alerts. So in this case, I'm monitoring the error rate from my test website that I'm hosting with this ingress, and I'm monitoring latency. So I said earlier, you can have warning and critical. So in this case, if my website's slower than 1 second response time for 5 minutes, it will send a warning alert. If it's 5 minutes, if it's for 5 minutes over 5 seconds latency, so really, really slow, that's a critical alert. So you can do this kind of thing to monitor additional things that don't come with the chart, and it's all YAML. You just deploy it with your application's YAML files, and there's no manual fiddling around with config files. It's just all YAML. And yeah, finally, I pinched this off of Grafana's really great, I don't know what they call it, but they've got like a dashboard marketplace on Grafana's website. So you can download the JSON for those dashboards and deploy those in config maps, and Grafana will automatically pick those up. So if I go here, I've deployed that config map with that dashboard, and it just appears here in my Grafana, and I can see response times, error rates for ingress in this case, but there's dashboards for pretty much everything you'd ever want to deploy in Kubernetes. So that's the first thing. So the other thing is black box exporter. So not directly related to Prometheus Operator, but there's another Helm chart you can deploy for black box exporter. What that does is polls HTTP endpoints. So say you've got something outside of Kubernetes, or you want to check that the whole routing all the way from your CDN all the way down to your application is working. You can poll that HTTP endpoint and get metrics for it and do alerting on it. So in this case, I'm just polling test.cablespaghetti.dev, which is a test website I spun up. And again, I put some Prometheus rules. In this case, the Helm chart supports Prometheus rules, so I haven't had to do YAML. I've just stuck it in my Helm values file. And again, I've deployed a dashboard, which it's slightly customized from the one on Grafana's website, but again, I can see how long this probe's taking on average, milliseconds, what each stage, so how long the connect takes, how long the DNS resolution takes, all that kind of thing, how long my SSL certificate's got left. And you can do alerts using Prometheus rules on all this stuff. So it's all in your Prometheus system. So finally, what about if your Kubernetes cluster goes down and you're running your monitoring for your cluster on your cluster? So you can, I said about the watchdog alert earlier, so that always triggers. So you'll see here it's firing. You can route that wherever you like. So I can send a webhook to some third-party service. There's things on the internet that do this. I think it's a dead man's switch website. That's what it's called, a dead man's switch system. So, however, I've basically, you can also hook it into PagerDuty if you're a PagerDuty customer. I've just spun up a simple AWS Lambda function in our environment. So this is something that we've just open sourced from Pulse Live. So you can deploy that in an AWS account. It'll cost you pennies to run because it's all serverless stuff. And so this trigger will come from Prometheus, go through Alert Manager, get sent to your AWS Lambda function. And if that alert stops because your cluster's gone down or Prometheus broken in some way, you can have that separately send you a Slack notification or an email, or in this case, it's a Slack notification that it supports, but you can customize it to do whatever you want. So that's a really useful thing, because that's something that is often missed, because if your cluster goes down or you have a networking issue, suddenly all of that lovely monitoring you've configured just doesn't work anymore. So it's worth considering. So yeah, we'll link to this. There's much more detail on here than I have time to go over right now, but we'll link to this in Slack, and I guess in maybe Twitter that is linked to after this. So great, that's me done.
Fantastic. Thank you very much, Sam. Doesn't seem to be any random questions. I think you've blown everyone's mind. It was a very extensive demonstration. That's very cool. Okay, so over to Kai for auditing infrastructure as code.
Yeah, sweet. Let me just sort out my screen share here because Keynote, basically. Let's see if that's gonna. Screen sharing has failed.
Right, Kai, whilst you're
Sorry, Kai, we've had a question.
Yeah.
Barrett, you should be able to unmute and talk.
So is that a question for me?
So Andy, you've gone again. Where did you see that question?
Barrett Shosta raised his hand in the attendees. So I've given him permissions to talk. I don't know, maybe it was by mistake.
Yeah, sorry, it was by mistake.
Okay, cool.
Cool. Right. Let's see. Keynote. I swear this was really smooth last time. Can you see a auditing infrastructure as code setups full screen presentation?
Looks good.
Excellent. Right. Phew. Worked. Right. My name is Kai. I'm a developer advocate here at Civo. And what that means is that aside from developing features for our website, which, you know, as has been said, it's mad busy, I get to rep presentations like this and do stuff with our community and encourage people to use Civo. So it's a fun job. We're going to sort of take a slightly different path now. We're going to be looking at a tool to audit your Kubernetes resources, among other things, but sort of, you know, in the vein of looking at your continuous deployment, right? So the scenario is you should know what you're deploying. Basically, how can you trust the configurations and code that you're running, especially you work in a distributed team, so you might have people sort of putting stuff in. You know, how can you be sure that all of that stuff is good? And then I've been on some Kubernetes user groups where somebody asks a question and, you know, like, how do I do X type of monitoring, you know, and, you know, it's like, is immediately the replies are like, just apply this, kubectl apply -f github.com/whatever. And then, you know, it's a question of like whether you should be doing that in the first place. So, and then how many of those deployments are made, you know, without second thought, and even if they're not malicious, they may be perpetuating sort of known best practice. So, and how many people actually bother to read through their manifest files with any regularity? What if there was a tool for this? Like, wouldn't it be great that you could have something do the heavy lifting of sifting through a bunch of YAML on your behalf? And, you know, you wouldn't have to worry so much. What we need is a static analysis tool. And for those of you who might be unfamiliar with the term static analysis, it means the analysis of code without actually running it. So you're not running it through a debugger step by step, you're having something step through the code without actually having to build it and run it. So it's sort of debugging in place. And then it'd be great to have a tool that could do that for YAML, because YAML. So, for this presentation, I'm going to use Chekhov from Bridge Crew. So what's Chekhov? Not that guy, that's Chekhov, the author. And that's Pavel Chekhov from Star Trek. We don't need him either, sorry. What we need is this. So this is Chekhov, which is a tool for auditing infrastructure as code, but also does analysis of Kubernetes components like services, deployments, things like that. It's not the only Kubernetes static analysis tool of this kind, but I found it neat because not only does it do YAML Kubernetes stuff, you can also run it against Terraform or any other sort of infrastructure as code things. So their website is chekhov.io. No, sorry. What I want to do is, sorry. What we're going to do is run Chekhov on a cluster and locally. So we're briefly going to show all the things that Chekhov checks for in a Kubernetes audit. We're going to run a check on a manifest file that I've pulled from k8s.io. So it's like a very sort of, recommended piece of thing. But as I mentioned, as the slides mentioned earlier, Chekhov is incredibly opinionated out of the box. So you'll see it spits out a bunch of sort of queries and not errors as such, but just failed checks. And then we're going to run it on an existing cluster setup and view the log that it creates. So I hope you can now see my desktop with the terminal on it. Thumbs up. Yes, cool. Excellent. So what we're going to do is...
You may want to make the font a little larger, though.
Yep, I was just about to ask that. How's that for you? Any better? Yeah, cool. So we're going to get the cluster analysis job going first because it takes a minute or so. So we're just going to basically create a job for it and then have it do it in the background. So what we're going to do is we're going to, I said I would show you all the checks that it runs as part of a standard suite. And there's obviously various frameworks. Like I said, it does Terraform, it does, various other things. So, there's a bunch. So there's 139 total tests from things like, are you using the correct namespace? And are you applying security contexts? And do you specify readiness probes and things like that? I'm going to run this same check on this file, which is from k8s.io, which is an Nginx, your basic Nginx sort of deployment. So we're going to do Chekhov-f, so for file.
Can't see the command.
Sorry. Thank you. Bear with me. I'm going to just resize my terminal. Can you see it there? Any better?
Yes.
So this is running through an existing YAML, and you can see that it has failed a bunch of these tests. Again, like I said, out of the box, Chekhov is very opinionated. It sort of does everything according to the book. So it passed 16 and failed 15 of its relevant things for this deployment. And if you then were to look at, okay, what does containers should not share the host IPC namespace mean? You can just go to the appropriate page. It describes what the actual rationale for the rule is and whether how you can remediate it. Assuming that you want to. If you don't want to remediate a rule, you can just specify in your runner, especially if you're doing it for CI/CD, to not actually skip the So let's say you don't care about rule 34, then you tell it to skip rule 34. And then finally we can quickly check up on our job that I just ran. So what I had is a cluster, 2-node Civo cluster with everything standard out of the box, nothing installed, nothing running except for what K3s on our service deploys out of the box. And yeah, there's a couple of things that, So for example, use read-only file system for containers where possible. You might care about that, you might not care about that. So there's various things that you can fix, and you can see handily exactly in the file concerned where the sort of component fails. So you can audit your code as part of an already existing cluster, or before you deploy anything. So you can run it on any kind of Kubernetes resource YAML files, or you can hook it up to your CI/CD system. So there's native support for GitLab, GitHub Actions, which have both been talked about, and a bunch of things like Jenkins. So you can you can have this run with your specific requirements on every deploy, which means that you won't ever be committing things that you don't think you should be. So thanks everybody for bearing with me. I just sort of whistle-stop toured through that, but I thought that as a tool that was quite cool. I'll be sure to try and answer any questions you might have. If you don't have a question you want to ask now, I'm pretty much always in the Civo community Slack, so you absolutely should ask me there and I'll try and help, or then rope somebody much smarter than me in, either from the Civo team or from the community. So yeah, thanks very much.
There's a couple of questions for you, Kai.
All right, let's have them.
So Ayani, how does this compare to most linting tools out there for Kubernetes manifests? Some people made a lot of manifest linters, but how does this weigh versus the competing projects?
This so from what I've tried, and I've tried a couple just to this one's faster. Like it plus the fact that then it does all your infrastructure as code setup, so not just Kubernetes, but it'll, you know, you can feed it Terraform scripts or anything else.
And the actual guides on their website as well for each of the rules look very cool as well. Give
Yeah,
more information on what it means.
Yeah, they're super informative, down to, like, you know, comment this line out if you don't want this particular thing to do, or you can change the parameters and everything else. So.
Or maybe if anyone's got any experience with any other tools, feel free to discuss them in the community Slack, and we can, yeah, keep going with the discussion there.
Sorry, there's a few other questions popping in now. I think this one's for you as well, Kai, from Nathan Thomas. How do you filter the rules there?
So you would, there's a command line option for skip, and then you put in the numbers that you wanted to skip, or you then, as part of your configuration file in your CI/CD job, you just tell it to skip whichever ones that you're not particularly worried about.
Okay, and just another follow-up question from Nathan there. Is it a job?
So you can run it as a Kubernetes job if you want. So I ran it on my existing cluster, but so if you were spinning up a cluster, deploying stuff on it, and then you could run it, or you can also audit in place the files before they even go on.
There's another question from an anonymous attendee. I think this, Andy, this might be for you. Do you think it's helpful if we can have checkoff static lint as part of the Civo feature?
It's a good question. I mean, the only thing is, as Kai's talk kind of highlighted, there's various ones where it's maybe up to you if you want to do that or not. I mean, it may well be the sort of thing that if people are running this and consistently finding issues within the cluster, maybe that's something we can change in the defaults. But again, we tend to stick to as standard K3S as we can. We try not to mess with it too much during installation. We want it to be compatible. If you just downloaded K3S, installed it on your machine, or you use that K3S service, we don't mess with it too much. So potentially, if the default K3S installation out of the box has some issues, then we'd probably look at either encouraging community to raise that up to Rancher's K3S project, or we could do it. But I think it would be sort of an upstream thing if it's consistently having issues that the community agrees should be fixed.
And one of the things that I really wanted to stress in that is that Chekhov is sometimes needlessly strict. So, and that's why I ran it on the official Kubernetes Nginx demo deployment, because it spits out 15 not errors, but warnings on that, which, you know, you wouldn't expect to be ever prone if they're offering that as here, try this as a deployment. So it's a little bit make of it what you will as a tool. It's not designed necessarily to be a one-size-fits-all solution.
Okay, another one from IAM on Chekhov. Would Chekhov rules update accordingly in a regular basis whenever there's a K8 API change? For example, resource X graduates to V1.
Yes. So what they do is, so if you're running it from their repo as part of your, so the way that you do your you integrate it with CI/CD is the same as you would with any other image. So you mark that image to be part of your job. It gets pulled, checked against what the current sort of version of those rules is, and then spits out the results accordingly.
Okay, I think that's covered all the questions. Is there anything? Oh, in comes another one from Ruan. How you doing, Ruan? Off topic, will the recording be available? Yeah, we'll get this on YouTube tomorrow, if not maybe Monday. But yeah, it'll be online. I'll let you know, Ruan. I'll pop you a message.
Just before we go, 2 other quick little bits. We've had a message from Alejandro. Alejandro has been working on a plugin for Packer to interact with Civo. So if you're a fan of Packer and a Civo Cube 100 member, feel free to check out the repo. It's on github.com/Civo, or reach out to Alejandro in the Civo community Slack. The other thing is, just for those of you that are very aware and raising in the community Slack, we're running an old version of K3S. The next task for me for this week is to try and upgrade us to the latest version. So hopefully by the end of the week, if you launch a cluster, it will get the latest version of K3S, not 1.0.0, and you won't have to use some development version hacks. So that's my goal for the next couple of days, is to get that fixed so we can stay up to date with their versions as they release them.
I think that's just about it. Just wanted to end on, I just noticed there's quite a few people in the community, in the participants attendees list here that I don't necessarily recognise. So if you haven't already applied for Cube 100, please do make an application, civo.com/Cube 100. It'd be good to see you, and then it'd be good to see you in the Slack community as well. And we can start working with you and building this community. Other than that, I mentioned in the last community meetup, ambassadors is very close, and we've got a few ambassadors who have kindly agreed to join us. They're basically doing an ambassador job for us already in the community. So these will be people you'll be able to approach, especially if there's a member of the Civo team not immediately available, and they'll be on hand to give you a helping hand when necessary. So there'll be more information on that probably within the next week or two. And you may have seen as well, Refer a Friend has gone live since we last did one of these webinars. So we've got lots of referrals coming in through there. And the good thing about that is if you put in quality referrals through, we'll actually reward you with actual cash rather than sort of any credit or anything like that. So check that out if you're already a member, and send over your friends. But I think that's about it. Same as last time, there will be a little survey, 3-question survey that we'll send out to you. It should appear once this webinar is closed. So if you just fill that in, and we can take that advice going forward for the next one.
Can I just say one thing as one thing to add is, if anybody watching this is interested in doing a talk, showing off something they've done or anything in between, just reach out on the Slack to either myself or Ricky. We do these calls once a month. So next one is looking to be sort of end of August. So we'd love, any sort of presentations for that.
Yeah, please just give us a shout or I'll come chasing.
Yeah.
Just from us again, thanks to the guest panelists again for today. We really appreciate your time in preparing for your talks and delivering them today and stepping up. So
thanks, guys. Great to have you with us. Okay, I think that's a wrap.
Cool. Take care, everyone.
Thanks, everyone. Bye-bye.
Thanks, everyone. Bye.